Today we are talking about a different place value. Um, we have talked about place value quite a bit already, but now we are looking at decimals. So our learning target today is I understand the place value of decimal numbers to the hundredths place, not the hundreds place, hundredths, Hundredths. So take a look at this smaller place value chart here. You'll notice the big decimal point between those numbers there. Once we are out of whole numbers, tens and ones, you can see here, we get to decimal numbers, tenths and hundredths. So these are smaller than ones, tens, hundreds, and that decimal point always separates whole numbers from decimals. If you leave out that decimal point, it vastly changes your answer, right? If that decimal point wasn't there, this would be 2,563. But in reality, this number is 25 and 63 hundredths. We always read that decimal point when we're reading a number as and. We say the word and. So, a decimal point will always separate whole numbers from decimal numbers. We call ones, tens, hundreds, etc., getting bigger, whole numbers because they are complete. If you think of decimals as parts of something, you would be correct. Decimal numbers are parts of a whole number. That's why they are separated by that decimal point. They are smaller, they're pieces of one whole. So the first decimal place to the right of the decimal point is the tenths place, where that 6 is. The second decimal place after the decimal point is the hundredths place, where that 3 is located. So here is a different decimal number. You'll notice there are no whole numbers. There's a 0 in the ones place, a decimal point, then a 2 in the tenths place, and 8 in the hundredths place. The number above is read as 28 hundredths. Notice how I didn't say tenths in that answer. That number there is represented to whatever place value it goes to. If there was only a number in the tenths place, we'd say 2 tenths, for example. But since there's also an 8 in the hundredths, we say 28 hundredths. This decimal represents part of one whole number, right? There are no whole numbers here, just the decimal numbers. Look at that hundreds grid to the right on this slide. You can count 28 shaded squares to represent that decimal number above. Each vertical column in that hundreds grid has 10 pieces, kind of like a rod with base 10 blocks split into 10 pieces. So if you have all 10 of those pieces in a vertical column, that's a tenth. There are 2 full columns filled up, right? So 2 tenths, that's where our 2 tenths comes from, this 2 up here. But there's also 8 hundredths. Single pieces are a hundredth. Since there's 8 of them, we have 8 hundredths. In that third column, those 8 pieces are represented by the 8 hundredths. So individual pieces, again, represent hundredths, like the 8 extra pieces in that third column. If we had all 100 pieces together, it would just be 1, right? There wouldn't be a decimal. If we had all 100 pieces, it would be a whole number. We'd have 1. Here's a couple different examples. You might see different combinations of decimal numbers. Let's look at this first one. 7 tenths, or in parentheses there, you'll notice it also says, or 70 hundredths. Those are actually the same thing, but the best way to write that would just be 7 tenths, 0.7. That's because we have complete columns. There are no extras after that last column. There are 1, 2, 3, 4, 5, 6, 7 complete columns in this first image here. So that is 7 tenths. In this middle one, 28 hundredths, right? I have a number in the tenths place and a number in the hundredths place. So that is 28 hundredths, represented by that picture we've already seen. There are 2 complete columns and 8 more in the next one. So that is 28 out of 100, 28 hundredths. In the last example, there are no tenths, right? So this is a little bit different for us in place value, writing this number. We skip over the tenths place, which sounds a little weird, but that's because this number is even smaller, right? There's not a full tenth. There's only 1, 2, 3, 4, 5, 6, 7 of those first 10 pieces in the column shaded in. So there's only hundredths there. Remember, individual pieces represent hundredths. So if I only have 7 hundredths, that's what it's going to look like on a hundreds grid there. And that number is read as 7 hundredths. But remember, you can't skip place values when you're writing numbers. That's why there's a 0 in the tenths place. Got to be very careful when you are typing or writing decimal numbers to represent the correct place value. If I gave you this image right here and said, write the decimal number for this hundreds grid, you would have to type or write 0.07 to make sure that 7 is in the hundredths place. Now, if there is only a digit in the tenths place, you say tenths. And if there is only or also a digit in the hundredths place, you say hundredths, right? We've kind of gone over that already in this lesson. So again, here's that example, 7 tenths, right? There are 7 full columns. There's no individual hundredths pieces left over. These are like tenths. You would say 7 tenths. As opposed to this one that we just saw, 7 hundredths, right? There are 7 individual pieces shaded in. Does not have a full column, so it's not a tenth yet. We only have 7 hundredths. Hundredths are smaller than tenths. So let's look at the original example we had on the first slide of the lesson. It is on screen on this slide, and because there is a number in the hundredths place, again, we say this number is 25 and 63 hundredths. Don't forget to say and for your decimal point when you're reading numbers. Or if you happen to be writing word form, you've got to say and to represent that decimal point. Again, notice how you don't have to say tenths in this case, right? I have a number in the tenths and hundredths place, but I'm reading this number as 25 and 63 hundredths.